again, in this lesson we are going to be looking at solving inequalities. In an equation, two equal expressions are being compared, but in an inequality statement, two unequal expressions are being compared. So we're talking about things that are not equal. This sometimes confuses students. This symbol is called a greater than. It's read as greater than, whereas this is read as less than. It kind of looks like an L. This with a line underneath it is greater than or equal to, and this with a line under it is less than or equal to, meaning it can be less than, but it can also be equal to. The graphing symbols we're going to come back to. This will be kind of like a reference point, but we're going to work through the lesson first before we fill that in. Alright, so what are some values that make the following statement true? X is greater than 5. Well, certainly it could be 6, it could be 7, so we'll jot some of these down. It could be 20, it could be 300, it could be 1 million. We could also go a little smaller and go with 5.1, 5.5, 5.01, but even smaller than that. So let's mark all of these on our number line here. So there's 0. It's always a good habit to put 0 on your number line. And then we're going to mark the important number 5 here, and then we can find some of our other numbers like 5.01, 5.5, 6, there's 7, 20 would be down here a little bit further, and 300 and a million are off the line to the right. So were we able to mark all the possible values? So are there other values on this number line that would work? Well, 10 would work, right? And what about 30? Yeah, 30 would work. And there's actually countless other numbers in between here that could work. So no, there are more possible values. And in general, they continue onward to the right, like 1,300,000 that we couldn't even reach. So is 5 a possible value for x? Could 5 be a point that does x is greater than 5? Well, 5 greater than 5, no, that's not true. That's not a true statement. 5 is not actually greater than 5 itself. So 5 does not work. So because 5 doesn't work, and we're putting points where things do work, we're going to put an open circle or a kind of a hole here, kind of a barrier, saying, nope, no points in there, not a point here. Points all the way over here to the right, but not a point where 5 is. So all of these are all points over this way. In fact, there's so many points that they get so dense that when points merge together like this, they form a line. So instead of making countless points, we're actually going to kind of shade in our line and show all these values to the right of 5 are all values that make the statement x is greater than 5 true. What would be another way we could write x is greater than 5 using a less than symbol? Well, we could flip this around. Now notice this is the same. The alligator mouth is eating the x in both situations. Does it change the value of x? Absolutely not. Same expression as before. Alright, so let's look at some possible examples. Let's kind of break this down into some scenarios here. So x is greater than -2. Values that would work for that would be like -1, 0, 1, 2, 3. But what about -2 itself? Does that work? No, -2 does not work. It is not greater than itself. So -2 is not a value. Because it doesn't work, just like before, we're going to make an open circle showing that there's nothing there. That is not a possible answer. We could kind of represent that with a hole, you might say. So let's draw our number line and make a visual of this. So we're going to put 0 and -2 as kind of our key points on here. And at -2, we just said that's not a point. So right there, we're going to put our open circle. And all these test points that we have are all to the right. So we're going to make a little shaded arrow going to the right from -2 as our starting point. X is less than or equal to 3. What are some points that would work for this? So let's jot some down like 2, 1, 0, -1, -4. All of those would be values that would work. What about 3 itself? Does 3 work? Yes, because 3 is less than or equal to. Because we have the or equal to part, it does work. So since we're shading, we're marking points that work, this would get marked with a filled-in circle. Sometimes call it a closed circle, because it's a value that does make this a true statement. So on our number line, let's go ahead and put in 0 and 3, kind of key points here. At 3 specifically, does this work? Yep. So we're going to put a solid dot right there. If we think about all these points that we said that would work, they're all to the left here. So we're going to just shade into the left and make a nice arrow saying there's even more to the left than we can even reach. So that's a visual representing x is less than or equal to 3. X is less than 7. Okay, so 6, 5, 2, negative 3, all of those work. What about 7 itself? No, 7 is not less than 7. It's in fact equal to it. So no, just like before, is going to lead to this open circle because it's a place that does not work. So it's kind of a hole there. So we're going to throw 0 and 7 on our number line. At 7, that key point, we're going to put an open circle, a hole there, because that's not a value that works. We're not marking it. We're marking all these values to the left, like negative 3, 2, 5, and 6, and we're going to put an arrow saying there's even more of them to the left. Greater than or equal to negative 6. Some values that would work here, negative 5 would work, negative 3, 0, 4 would work. What about negative 6 itself? Yes, again, it does work because we have that equal to bar. Yes, kind of corresponds with a solid filled-in circle because we can mark that point as a value that makes that inequality true. So we'll put negative 6 and 0 on our number line, and negative 6, our key point, that does work, so we're going to make a solid filled-in circle there, and our points are over there to the right, so we're going to make an arrow that goes off to the right. Those are our possible values that make this a true statement. Now notice, if x is on the left side, so it's x and then our inequality statement, the arrow in the of the line is the same direction as that inequality symbol. So if the variable's on the left, it's almost like telling you, look, this is like an arrow itself. It's going that direction. But it has to happen when the variable's on the left. That's the only time that works. All right, now we have some one-step equations. We have to do a little bit of solving first. Pretend that inequality sign is an equals. What we would do is subtract 5 from both sides, just like we've been doing. That gives us x. Bring down this symbol. It's not an equals, but we're going to bring it down just the same. And x is less than or equal to negative 3. The solving step, pretty simple, but that's only part of our answer. The other part is the visual representation, which we're going to put on the number line. So negative 3 and 0 on our number line. It's a filled-in circle there at negative 3 and to the right. Those are all the possible answers that work for that inequality. And they work for the original x plus 5 is less than or equal to 2. All right, solve here by negative 7. That's half our answer is 3 is less than y. And we're going to make our number line 0, 3, open circle this time on 3, because 3 does not work for 3 is less than y. And then we make our arrow to the right. If you wanted to, you could rewrite that as y on the left side. Make sure the alligator's still leading the y is greater than 3, so we kind of see which way the arrow is going. Here again, we add 9, and we have 18 is greater than z, so 0, 18, open circle there, and we're going to go to the left. And those are all our possible values. So all of that is our answer, the algebraic answer and the number line. Let's rewrite this as w minus 14 is greater than 2.5, and then we'll add 14 to both sides, and w is greater than or equal to 16.5. So 0 is there. I'm going to mark 16, 17, and then 16.5 would be right there in the middle. And now we can close circle that because it could be equal to 16.5, and then all these values to the right. So those are our visual representations. So we'll go back to the beginning. Let's just kind of complete our little reference chart here. For greater than and less than, there's open circles. Those do not work. For greater than or equal to or less than or equal to, filled in circles, because those are possible answers. They are equal to, those work. That's a good reference chart for us.